which again is a recap of algebra 2. Okay, so when I see f of negative 2, what does that mean? Brian? Good. When x equals negative 2, and what do you have? 5. How many of you agree with that? Good. All right, now on the flip side, f of x equals negative 4. What does that mean? Mia? All right, and what do we get for x? Good. Awesome. Okay, so when x is equal to negative 2, go to negative 2 and see where the graph intersects. Okay, then when y is negative 4, go down to negative 4 and see where the graph will intersect. Okay, now what is the domain? Brian? Good. Negative infinity to infinity. What is the domain? Again, what values? X. Good. What would be the range of this function? Go ahead, Brian. Excellent. Why would the range be negative infinity to infinity instead of a common mistake, negative infinity to 5? Go ahead. Good. There's arrows. And here's an extension. Would this be an odd or even function? Yeah. Odd, right? Because it kind of resembles a what? What is that called? You're right. What's the basic function you guys have learned for years? Do they look like this? Or like this? Linear, right? It resembles a line, right? We've seen the cubic functions, we've seen quintic not so much, but again, same concept, opposite way. All right, where's the y-intercept? Let's see. Allie, go ahead. 0, 0, good. And what are the zeros? What's another name for zeros? Right. Good. 0, 0. Excellent. X-intercepts. Okay, 0 is the same thing as x-intercepts. Now, intervals of increasing and decreasing only have what? Yeah. X values. Good. Excellent. And we should only show what? How should I write them? With parentheses only. So both of these are parentheses only in which with your x values. Okay. So what are the intervals of increasing? Go ahead, Liz. Mm-hmm. Good. Okay. Negative 4 to negative 2. The u means it's also occurring. Okay. 1 to 2. So we have to make sure we include that union there. All right. Intervals of decreasing. Go ahead, Bri. Mm-hmm. Mm-hmm. Excellent. Good. So, and again, just a little recap. Okay. Increasing and decreasing should fill the spots of one another. Okay. So if you notice the domain is from negative infinity to infinity, negative infinity and infinity should also be included. Okay. So it's just piecing out the domain. What does this notation mean? Go ahead, Mia.
When x is equal to negative infinity, what is your y value?
Excellent. And what is it? Good. And the other one?
When x is positive, y is negative.
Excellent. Okay. This is called, we're going to get more in detail with this, but end behavior. That's where the graph is heading. Okay, the end behavior. All right. So how'd you guys do with this first part? Pretty good, right? Remembering? Awesome. Good. Okay. Whose phone? Describing sets of numbers two ways. Okay. We have inequality notation, which is this guy here. An interval, which is what we're going to use a lot of. Okay. Again, U can be used for or, but it's read as union. Okay. Equal to uses less than or equal to or greater than or equal to, and that's where we use the brackets. Again, we're just recalling this information. Not equal to has the less than or greater than without the bar underneath, and that's equivalent to parentheses. Which two numbers per se will always have parentheses with them in terms of notation? Excellent. Negative and positive will always have parentheses. Okay? And it was right here, the next line. But yes, it would always have parentheses. So, here we have a compound inequality. Negative 8 is less than or equal to x, which is less than 16. How would I write that in interval notation? Juliet? Good. So I would have a bracket on this side. Excellent. In parentheses. Good job. Okay. So the bracket because it's equal to, parentheses because it's not. All right. Now we have x is greater than 0. This, how would I write it in interval? Go ahead, Liz. Good. And what would they have? Careful. Both parentheses because it's not equal to. Okay. Good. Excellent for remembering that. Okay. So this one, we have x is less than negative 3 or x is greater than or equal to 4. Okay. So it's kind of going to resemble this one below, C below. How would I write that? Bri, go ahead. Close. Okay, really close. Think least to greatest of that first. Okay. Negative infinity, negative 3, and then this was correct. What do I have to include in between? The union, because the union means or. Okay, so negative infinity to negative 3, union, 4 with a bracket to infinity. Do you guys see that? All right, now we have x is not equal to 7. So this might help with that. 4, 5, 6, 7. Here's negative 7, right? Go ahead, Liz. No, you have the right idea. Keep the numbers. You don't have to change to 6 and 8 because 6 and 8 are still included. Yep, that's it. So negative infinity to 7, still with the parenthesis, union 7 to infinity. Oops, this should have been positive 7, but okay. So it should, you're still including the number that is given to you here, but the parentheses mean it's not included. So it's kind of just skipping over 7. Does that make sense? Okay. So now if we go the reverse direction and go from interval to inequality, what would we have? So we have 2 with a parenthesis, comma, 5, bracket. And if you notice, they're very similar to the ones above. Okay. All right, Bright, go ahead. Mm-hmm. Okay, so, oops, positive 2 less than x, which is less than or equal to 5. Is this what you have? Okay, good. So 2 is less than x, which is less than or equal to 5. Okay, since it is a range, we're going to include the compound inequality. And if you notice, the signs are always going in this direction. Always. Okay. How would I write b? We have negative infinity to 0 with a bracket. Kate? Excellent. Good. Perfect. Right? All right. How would I write this one? There's two ways you could actually write this. Is that yours? It's okay. Go ahead, Juliet. Good. Okay. X does not equal 2. That's pretty much what we could write. Okay. We could also write, since this means or, X is less than 2 or X is greater than 2. Okay. But the simplest version will be X is not equal to 2. All right. Now for D, what would I do? Any ideas? Got it? Okay. Okay, you have both. You could just stick the or in there. So, if you did x is equal to 5, which you are correct, or x is greater than or equal to 7. Okay, nice job, Brian. Okay. So, going from inequality to interval, we will see. Okay. Inequality, interval, we will see. All right. Just remembering what interval notation is going to be huge. Okay. Because again, we see that a lot. All right. If we turn to the next page, look at all the functions pretty much you guys covered last year. Okay, we're going to do a little recap. Okay. So we have a constant, which is just a horizontal line. We have our linear function, which is diagonal. Okay. Our quadratic is a parabola. All right. The cubic is like that squiggle line, right? So my question to you is, what would be the domain of a horizontal line? Go ahead, Brad. Yep. How about linear? Same. Good. Quadratic? Same. And cubic? Same, right? Okay. So for horizontal lines, diagonal lines, parabolas, squiggles, we have our constant, linear, quadratic, and cubic. The domain is all the same. It's just continuing.
Good morning. At this time, all ninth graders, please report to the auditorium. All ninth graders, please report to the auditorium.
All right, then we have our absolute value, which is V-shaped, okay? Then we have the square root, which is half of the parabola because we can't have the negatives. Then we have the cube root is always the sideways squiggle. Okay, so what would be the domain of the absolute value? Excellent. For a basic square root function, what would the domain be? Brad? Excellent. And that has a bracket, 0 to infinity, because that is the smallest x value you could have. Okay? And how about the cube root? Same. Good. Okay, because it keeps going. Like that. Okay? All right. Now our lovely exponential graphs. Okay? Our exponential graphs, what is the difference with this? Okay, we have our domain, which would be what? It would still be the same. But one thing about exponentials is what? Yeah, Brian. The range is different because why? Good. In these two cases, it will never cross 0. Does anyone remember the name of that? It is an asymptote. So the range here, since it's approaching 0, is 0 to infinity. Okay, with a parenthesis, because it's approaching, it's getting very, very close to it, just never crossing it. Okay, and the same thing applies for exponential decay. Okay, and then we have our piecewise graphs, or pieces of graphs to create a function. Okay, we have first graph with our interval. Okay, tells us a specific domain. And then another graph with another interval notation. Okay, we're going to see the difference between domain and when we use continuity as well. Okay. All right. So, what I want you to try with a partner, okay, and I'll leave them up here because I know some of the graphs didn't copy too well. But I want you to try to figure out using interval notation, okay, the domain and range of each, okay, all 4. So if you have pencil, I highly suggest you use pencil, which I think all of you do. So try 1, 2, 3, and 4 with domain and range. Go ahead. Yeah. Interval, so parentheses or brackets. That's the one we're going to use more so. They could be a little tricky, and yeah, it's definitely stopping there. Okay, so what is the domain of number 1? Liz? Good. Negative infinity to infinity. What is approximately the range? Go ahead, Bri. Good. And 4 bracket. Perfect. How many of you did get number 1? Correct. Okay, it's negative infinity to 4 because that's the highest y value we have. Okay, now let's look at number 2. Okay, what's happening in number 2? Any ideas? Go ahead. Okay. Okay. Any ideas? So move your pencil left to right. Okay. So you're looking at this as a whole. All right. So we have negative infinity. What is the first roadblock? What don't we cross? Negative 3. Okay. Union. And then we go from negative 3 to where? Careful. To 2. Union, then where? 2 to infinity, okay? The reason is, okay, so as you're doing domain, you want to use your pencil, okay? Scroll all the way across, and we're looking at x values. So negative infinity, because we have this arrow, we have a roadblock of -3. We're getting these dashed lines mean asymptotes, okay? We're getting very, very close to it, just never crossing. So -3 is our asymptote. Then we continue from -3. However, there's an open circle, which is a hole. That is called a hole, okay? So that's not included in the domain. That's why we have a space for 2, and then it continues to infinity. Do you guys see that? Yeah? Okay. Now if we look at range, okay, from bottom to top, okay, from bottom to top. So we have negative infinity. Our first roadblock is going to be this open circle at where? -1. Then from -1 to the asymptote of 1. Then from 1 to infinity. Yep. Okay. All right. Do you guys see that? Just want to make sure. It takes a minute to process. Okay. So from bottom to top, negative infinity, good, good, good. Oops, we have an open circle at -1. Skip over that. -1 to our first asymptote, which is 1. Then, close parentheses, from 1, we continue on. Okay? All right. Number 3, these stop at 8. There's no arrows, so we're just assuming they're solid points right now. What do we have? Go one piece at a time, looking at the domain. Where do we start? Go ahead, Ella. Good. Good. Okay, I'm going to continue one thing for you. If you look at from -1 on, okay, looking at our x values, these are on the same line, right? What is one of the rules? Closed circle overrides an open, right? So is 3 included in this graph? Yeah, because even though there's an open circle here, there's a closed one here. If they were both closed, it wouldn't be a function. Okay, do you guys understand that? So we go from -1 to 3, but can we continue on to 8? Where it stops, it's not an arrow. Can we stop here? Can we continue? If you wanted to break up the piece, you can, but not necessary. Okay? So if you went from -1 to 3, union, 3 to 8, it means the same thing as what you see here. Because there's a hole and then there's a solid circle. Does that make sense? Okay? Because I know there was split, okay, in some of my classes last year, and this should be a bracket around 8. Some of my classes last year did both. Either -1 to 3, union 3 to 8. Okay, still means the same thing because it's continuing. It's not stopping. All right, let's look at the range. Okay, and I want you to keep that in mind. Closed circle overrides an open. Okay, closed circle overrides an open. So let's look at the range. What is our lowest y value we're working with? -6. It's hard to see. -6. Okay. -4. This is open, but is it closed over here? This is open at -4, but is it Closed here. Here's open. Is it closed here? Yep. So we're good. -6. If I continue, what's the highest y value? 8. Okay. Okay. How about number 4? What would the domain be? And those little tick marks go by 2. Okay. So what would our domain be? What do you think, Brian? They go up by 2s, so you're close. You're there. Perfect. Okay. What would the range be? Go ahead, Liz. Good. 0 to 4, both brackets. Remember, closed circle overrides the open. Okay. Closed circle overrides the open. Okay. So this is pretty common. Domain is always with parentheses, -infinity to infinity. Why? Because it's continuous. Okay, it's continuous. It just keeps going. It doesn't stop. And that's where we also have our arrows. Okay. Now, if we had a look at the range of a polynomial, it depends on the end behavior. Okay. So I want you to think of an even degree, like quadratic, quartic. Okay. What would the range be? If you could put it into words, what would the range be? Yeah. Yep. What would the range be? So if I had what would the range of this function be? Yeah. Careful. Least to greatest. -2 to infinity. Okay. If I had, that's fun. What would it be? 1 to infinity, right? Okay. So if I could put that in words, if it's a positive even degree, how would I write it? Like if this is -2 to infinity, this is 1 to infinity, and it's positive because both arrows are pointing up. So what is that lowest value called? Yeah. It could be, yeah, but if I just moved it over, right? It is considered the vertex, okay? But what would be that lowest point? Yeah, the minimum, okay, which both of you are correct in terms of the y-intercept or the vertex, but for the range, we're looking at the minimum value, right? So if it's a positive, you have a bracket to infinity, okay? But what would happen if I had a negative even degree? What would be different about the range? Julia? Excellent. So if it's a negative, you would have -infinity to whatever the max would be. Okay. Now with odd degrees, what would the range be? Think of a line, think of cubics. Yeah. Yep. No matter what the leading coefficient is, either negative or positive, you're always going to have -infinity to infinity for odd degrees. So that's x cubed x to the 5th, this was x squared, x to the 4th. Okay, all right. So I think the hardest part in terms of domain is remembering the holes. Same with the range. The holes, the jumps, the asymptotes. That's where it gets a little tricky. Okay. But to kind of recap again, if you turn to the next page, there are 4 functions you are familiar with. Okay. 4 functions you are familiar with, and they're up here just in case you can't see, that I want you to determine domain and range of each. Okay. So 4 functions you are all familiar with. Go ahead and figure out the domain and range. And one has, good, excellent. Okay, for number 3. Go ahead, Liz. Yep. 1 has parentheses because it's moving up 1 and we have our asymptote at 1. Okay, good. How about, go ahead, Liz. Yep. Perfect. Good. Okay. How about domain and range of the last one? Ella, what do you have for that one? Excellent. Good job. Okay. Awesome. All right. So again, pretty straightforward. These are our common graphs that we will see. It gets a little tricky again with the holes in the asymptotes. All right. And then as well as word problems. Okay. Determining what is a reasonable domain and range. Okay. I'm just going to cross out 3 and 4 because there's not enough information. An aerobics class is being offered once a week for 6 weeks. The registration fee is $15 and the cost for each class attended is $10. Determine the domain and range for this scenario. Okay. All right. So how can I figure out what the equation might be? Mm-hmm. Yeah.
Would it be something like f of x, and then you'll have like 6x plus like 6 times x?
Okay. The class is being offered for 6 weeks, so that has to deal with the domain. Okay. Look at the registration fee is $15 and the cost for each class attended is $10. So that's where you're going to create your function. Any ideas? Yeah. Yeah, that's it. Okay. So f of x equals, for class attended is $10 per class, right? So 10x plus the registration fee of 15. Okay. So now the reasonable domain is x is represented each class, so once a week. Okay. X is represented the weeks, right? So x is equal to weeks, and the f of x is obviously the cost. So if our domain, what would be a reasonable domain for this? Go ahead, Julia. Perfect. 0 to 6, because that is talking about the number of weeks. Okay. Now, what would be the corresponding range? Julia? Careful. Careful. 15 is right. Perfect. Good. Because, okay, the range has to match. If we substitute 0 in for x, we're automatically paying $15, right? When we substitute 6 in, we have 6 times 10, which is 60, plus the 15, which is 75. Does that make sense? Okay, so let's see, does this say? Yes. Okay, I want you to try with a partner number 2, and this is pretty much where we're going to end today. Try with number 2. It's a little bit different. Let's go through number 2. Okay, so what do we have? Go ahead, Allie. Excellent. Yep. Good. Perfect.
You know, I would not be able to pass a class in the school when it comes to math.
I don't know her phone.
17.
Okay.
You guys are all friends.
Okay, so Allie said everything correct. Okay. Why was the domain 1 to 4 instead of like 0 to 4? Or how did we get 4? Brian?
I think it's 1 to 4 because it says
Good.
4 because there's 2 points type values. And the entry fee is 45, so she can work the maximum 4 hours on top of that.
Perfect. Yep, exactly. So we have our domain is 1 because it's at least 1 hour. Then you have to set up the equation 5x plus 45 since you only have $65 to see what the maximum number would be. Okay, so if you took 5x plus 45 equals 65, 5x equals 20, x equals 4. That's how we get the maximum of 4 hours. Okay, and the range has to match. So when we plug in 1, we have 50. When we plug in 4, we have the 65. Okay? Good? We are good. We did a lot today. Good job. All right. So